Hi, everybody, and welcome to another VITA Academy webinar. Today we have Mr. Felix Pages. Hi, Felix. How are you doing?
Fine, thank you.
Good, good. So, how's Florida? You still got the fan going on in the back, so must be a little hot.
It's always warm here, even though I have a good air conditioner. But I changed my roof before hurricane season, and I used to have barrel tile, and I put shingles, and it's about 7 degrees hotter inside the house, believe it or not.
Oh, wow.
So yeah, it's okay. I'm used to it.
Yeah. Well, today we're having Felix go over Zirconia. Felix has got a lot of in-depth working with zirconia and the mechanics of it and the chemistry of it and the processing of it. So we're going over the laboratory processes that can positively and negatively affect your work. So the workflow and areas in which you can, just remember to do the right things on processing for the best outcome. So we appreciate you doing the program today. Um,
It's my pleasure.
so those of you that are attending today, your phone is on mute. So you want to make sure that if you have any questions, we're going to take questions at the end of the program. Type in the chat question box your questions, and we'll get to those. If it's something urgent, we'll stop Felix and just ask the question during his presentation. Otherwise, we're going to do it at the end of the presentation. The program itself is going to be recorded, and we will post the recording on the VITA North America YouTube channel in a couple of days. You just have to give us a chance to kind of reformulate it and post it. Also, those of you that are interested in CE as well, those will be a process as well using your registration information. So Felix Pages down in Florida, been a technician forever, forever and ever. I'm trying to get him to write a book, but he's not quite done with it yet.
I'm still learning.
Got to give away all those trade secrets, for the next generation of technicians.
I have a few in here, but most of the information, they don't even use the materials anymore.
Well,
That's why I have to learn a lot more about present day stuff, and then it's in the works. I just it's not easy to do it the right way.
That's right. That's for sure.
So
All right, so I'm going to turn it over to Felix. So if you're ready,
I'm
you
ready.
your screen and we can hear you. So go ahead and start your presentation.
Well, thank you, everybody. Most of the material that I am going to show you is something that I've researched, looked at, I don't even know how many articles. And you have to remember, zirconia has been around a while, but the changes that have undergone in the manufacturing of zirconia and the different types of zirconia and all the different people that make quote unquote pucks, whatever you want to call it, it's really unbelievable. And it's almost impossible to keep up with what everyone is doing. So you have to look at the general materials that are being used and look at evidence-based articles by researchers and universities to really figure out what's working and what's not working, and what's complicated and what's not complicated. So if you look at dental zirconia, it's a really difficult material to understand. Even my friends Russell Giordano and Dr. Bob Kelly, I know Bob called zirconia dark magic because there's so much stuff going on in there, and it's really hard to pin it down. This picture that you have here are 6 anterior units that we milled out with a type 5 zirconia, which would be 5 yttria content, the XT from VITA. And on the left of my screen, you'll see it where it's kind of polished a little bit. And then I glazed it and I put a little bit of gingival color. And these materials are so translucent sometimes that you have to be really careful. So we have gone from an ugly, opaque material to something that if you really have your stuff together, you can make a real nice single tooth restoration and blend it in pretty well. The limitations of anything that's I don't know, even if it's a multi-layer puck, it will never have the internal effects that a tooth has. So it's always going to be a little bit of a compromise. It's just that the doctors have to understand that. And you can quote unquote color in or stain in some stains on the outside. But we know that some of these external glazes can go away after a while, so you have to really be careful. And if it's a really, really difficult situation, you're going to have to decide whether you want to layer it with some porcelain ceramic material or just go with it. Remember, it doesn't matter how many layers of color a puck has in it. That doesn't mean it's going to fall exactly in place where the tooth may have some color or not. So it's really a complicated situation to do what I would call proper nesting. So zirconia is basically a metal, zirconium. You mix it with oxygen and yttrium, which stabilizes the crystal structure. They're both metals. Once they're oxidized, they become zirconia and yttria. I see a lot of people calling it zirconium crowns, and I corrected one gentleman on a text, and he cursed me out basically. So I didn't mean any harm, just trying to explain how you really should call these things. So you have dental zirconia compositions. These happen to be the some of the VITA material. This is the VITA YZT and the HT, which I don't believe very many people use it anymore. These are type 3, 3Y zirconia, which are very strong. But you see all these figures are all over the place, and it's hard to pin down what they actually used. Every manufacturer is that way. But basically, they have almost identical, except the erbium content in the erbium oxide on the VITA HT material. Besides that, everything looks the same. So you have a basic chemical composition, and then that produces some type of a microstructure, and that gives the properties of the material. So you can have very, very similar chemical compositions with just a little bit of change. You can create a whole new microstructure, and there you have a whole bunch of new properties like more translucency, less translucency, higher strength, lower strength, etc. So there's not that much difference in some of these things. Dr. Kelly, who was in the ISO, the dental representative, the technical committee, used fracture toughness has been observed to generally correlate with clinical indications. So now the new ceramics just entering the markets can be grouped accordingly with some assurance that their clinical indications will be similar to those used to develop the classification. This is where you see these ads everywhere that these materials have millions of megapascals in strength and all this business. So when you really do some testing, they're really not as high as some of these manufacturers claim they are, but they're still, most of them are still strong enough. The danger is if you put too much grinding and too much air abrasion on them, which can reduce the strength significantly. And I'll go over that later on in the presentation. So you see this chart here, and I know it's hard to read, but I don't know they like to use black ink. It's just too weak. But basically you have type 5 where it says monolithic ceramic for prosthesis involving partially or fully covered substructures, 4 or 5 more units. fully covered substructures for prosthesis involving 4 or more units. That's the highest classification of strength, and they have to measure 800 megapascals in fracture toughness, or what they call a K value. And of course, the chemical solubility is excellent in all of these. And so when you look at the regular porcelain that you just put on porcelain fused to metal and things like that, they only have about a 50 megapascal strength. It's amazing that you have PFM crowns that have been in the mouth for 40 years with very, very little wear. They'll wear the hell out of the teeth, but they won't break. And it's because of a good metal framework underneath and proper firing. So you have to understand that the stress and the cooling have a lot to do with the success of veneering materials, and we'll get into that a little bit too. So if you look at classification 4, you have a lot of the Emax, Saprinity, and glass ceramic crowns. They're very close to the strength of some of the 5Y zirconia without the chances of it getting weaker once you air abrade it. So you have to really think of what it is you want to put in someone's mouths. I found this on the internet. It's called Digital Dentistry Consultancy. And I found it amazing. I've never heard of this group before. They are out of Australia. And this fellow decided to do a corporation for training. And he has steps on how to prepare teeth for digital scanning. And it made perfect sense to me. I mean, ever since I've been in this business, which I graduated in 1976, I started doing lab work in 75 for the VA hospital in Lexington, Kentucky, through the school. And I remember the preparations that I was getting, and I said, these don't look anything like what the Typodont models that were given to us. You know, the wax patterns come off real easy on those Typodont models. But when it came to looking at some of this stuff, it was like, what is this? And so when you have a scanner and you're trying to scan these preps, if they're too rough or if they have an undercut or they're too sharp, the milling machine cannot duplicate this because they're too sharp. And so this guy has some guidelines, which is very helpful. So if you can look up Digital Dentistry Consultancy, I think it'll help your dentist quite a bit if they care. So you see, you need a nice, smooth, polished prep. When you do a scan and that little light goes in there, it can pick up every little nook and cranny. And so what happens is you need rounded point angles. You don't need any corners. Zirconia or glass ceramic crowns, they like curves. They don't like corners. So that I have shown in a lot of the work, I do too. I round the preps deliberately to show the doctor, look, you see here, this fits right perfect down here. The corner, sometimes they have a stress mark after they try to push them in because it just doesn't conform. And the diameter of the burst for milling, if you look at Roland, Amann Girrbach, I mean, every manufacturer and millions of them, you can get milling burrs. Every machine has a little bit of a different setup. And since this material shrinks from 22 to 25%, there's just a certain amount of burr that can fit in there. So if the prep is too sharp, the burr can't get in there. So what it does is it hollows out that incisal area, and then we would get the copings years ago on a CEREC machine, and there would be like a little bump on the facial, and I'm like, why in the hell is that thick there? I mean, I designed it perfect without thinking that the burr couldn't get in that fine edge. And then, of course, I'd try to finish it down, and you poke a hole in it. So you have to think of that. I used to take the burrs and give it to the doctor and say, here, put that on the incisal edge of your prep. And if the prep is bigger than that, we're good. If it's not, you got to round it off or flatten it a little bit. Do something, but that burr, it doesn't fit right. And then what happens is the crowns and the copings bounce on the margins and they tell you it doesn't fit right. And that's because they've opened up everything to accommodate a bad prep. So no sharp angles for digital dentistry or regular dentistry. Rounded edges is the same thing. It has to be smoother than a regular impression, and you got to have clear, distinct margins. That's what I've been trying to tell the doctor since 1976. But for, and my belief is that they can't see any of these things because some of the teeth that they prep are sort of translucent, especially older teeth. And I told one, I said, just dry the tooth off and put white out on it. And that'll make it look like white plaster. And then you can see the sharp angles. And he's retired now, but he used that all the time. And I got tired of having to deal with taking these things back. I can't do this crown on this because I'm not going to risk my crown because of a crappy prep. It's just not going to happen. So you got to send it back and try to explain to them logically why you're sending it back. Dr. Giordano sent me this picture. This is a long time ago in a galaxy far, far away, where I got a model to do some anterior crowns, and they were so sharp. This was even before the milling days, to where there was no way that I was going to do the crowns on that. And then I said, you know what? I could shave with these preps. So my secretary took this picture, and I forgot all about it. And Russell sent it to me yesterday, and I appreciate it, Russell. Look at my hair. It was dark then. All right. So this digital dentistry consultancy has recommendations for clinical diamond grit size. And you can see the different color of banding in all of these. And so this guy actually uses a white stone to really polish the prep. I've never prepped a tooth in the mouth, so I don't know what white stone he's talking about. But a lot of these diamonds have really, really fine grit sizes. But some of the doctors that they use those football diamonds that are pretty rough. Take the prep down, and you can actually see the lines in the preps. That's not good for the scanner, and the CAD/CAM machine will compensate for those micro undercuts and block them all out, and that's why you get loose crowns a lot of times. So they have to do a much better job prepping and rounding off point angles. Puck and block makers, there's too many to mention. I literally am going crazy when I open up and I put manufacturer of dental pucks, and billions of these things come up from all over the world, which the only determination I can make is that they can't be that hard to make if so many people are making them. But not all pucks are created equal. You have to really do a good job in this. And I still don't know exactly the procedure on how they get all these layers. But, don't overcomplicate things. Toso from Japan, this is a study done at the university, I believe it's Tokyo. Anyway, these researchers, they work very closely with Toso, which is the largest manufacturer of medical grade zirconia, to my knowledge. And they have made, this goes back a few years to 2014. And so what they've done is they've refined the grain size of crystals, et cetera, et cetera, et cetera. So where they're producing nanocrystalline ultra degradation resistant zirconia. And so they have a very good article on this if you want to look at it. You notice it's not even a dental journal. It's a scientific reports. And so it's a ceramic mechanical engineering paper. And it's amazing what they've done to improve the zirconia. So some of the stuff we're using today is made by Toso, and the raw materials, I believe that most of them are Z-Pex and Z-Pex Smile. And the Smile is more translucent than the other. But most of these materials are purchased from Toso, and then they make all the pucks. Let me turn my phone off here. So the problem is how do you make the pucks? And so typically, Toso sells a lot of powder. We had a friend of ours in Boca that wanted to do electrophoretic deposition of zirconia, and he wanted Toso to get to send them, like 100-gram sample to see if he could plate it. And the guy at Toso asked him how many tons he wanted. He goes, they sell it by the ton. At least they did back then, and so he got a good learning lesson. So they sell these spheres, and then the manufacturers like VITA or whomever is going to do it, they grind away and smash, and then they make the pucks. And the key thing that I've gotten out of this is you have pressing, which you just smash it down like if you're pushing down on a pancake, but then you put it somewhere else where you smash it from all directions. Isostatic pressing, and that really eliminates most of the porosity. And then they have a binder to hold everything together, and the material is cooked at about 1,000 degrees, which will hold the particles together well enough for a milling process. And then, of course, once you mill your units out, you can go ahead and finish them down and cook them, sinter them. So as it stands today, and I can add another number to the Y on the 6Y. Basically, you have three of the most common zirconias used today are 3Y, 4Y, and 5Y. If you use any Nobel BioCare abutments, which I'm trying to remember the name because I'm losing it, but these guys, they make an abutment that goes on a little tiny tie base, and then you tighten it, and this little three-prong titanium thing pushes out and holds a molar. It's unbelievable. And we haven't had one break except on a on a canine with a natural premolar. And when it went into working, the premolar moved a little and the canines cracked. That's the only ones we've been able to detect. So we don't use those on a canine. But they still use a 3Y zirconia, and it's very opaque. So if you're going to do an anterior case and you're going to use a Nobel BioCare, you're going to have to layer because there's no way that you're going to match the shade with that opaque of a material, especially when you have, a pretty thick zirconia. The medium strength, what I would call medium strength, the 4Y zirconia, that's really all they did was lower a little bit of the alumina content. Glidewell, I think, was the first one to do it with the Brookseer. And then you can use those on pretty much anything. And the low strength is the 5Y zirconia, and that's the most translucent. It has a very, very high cubic content, which is larger crystals. And you can only use them on anterior crowns. And those are the ones that are susceptible to too much air abrasion. They can really weaken the strength. So this is the way that I look at it. So if you have ice cubes and you crush the heck out of the ice cube and you have the little, what do you call it? The shaved ice in Italy. That stuff is white as white paint. And then when you use a snow cone, you put the liquid in it and it takes on the color of the liquid. It's similar to what happens to zirconia. And then the more translucent, you have much larger crystals, cubic crystals. So the light can go through them, but they're a lot weaker. And I've read a couple of papers and I've seen zirconias now that are up to 6Y. So I don't know how they work all that. That's beyond me, but just have to be careful in the incisal area, no question about it. So when you start to look at average values in regards to translucency, you start off with a millimeter sample. That's a fairly reasonable thickness for what? For a coping maybe? So when you start to look at the crowns, the zirconia crowns, you have the T material, which is 3Y, and the HT, which is 3Y with a little bit less alumina, which increases the translucency, and the ST and the XT, 4 and 5, that really increases the translucency. So what if you have a crown that's 2 millimeters thick or a big molar? So you have to understand that the thicker your crown is, the more chroma it's going to have. The worst case scenario is when you're doing a larger case and you have abutments and then you have Pontics or an implant restoration next to a Pontic, to where you have a Pontic that's huge, a molar, compared to, say, a millimeter, millimeter and a half maybe. So when you fire these things, the molar, you have to cook it slower because the molar won't cook all the way through. If you cross-section some of these things, you can see that it's still white inside because it's not cooking the right way. So this is from Toso because they're the ones that make the material for VITA. You can see the technical report there. So most of these ST material and HT material, if you look at the HT at 1450, it has much smaller grain particles. It's a stronger material. You have to look at these things like if it was a jigsaw puzzle. So I used to dread coming home when my mom and dad were putting jigsaw puzzles together, which a couple of them occupied half of the dining room table. And of course, any of us 3 kids that walked by there were automatically volunteered to put pieces of puzzles in there. And I used to hate that, especially the ones my mother would get with all these flowers everywhere. I didn't know where one started and the other one finished. But eventually they got done. And this is what 3Y, 4Y, 5Y zirconia. You just have the same size of a jigsaw puzzle with smaller pieces or larger pieces. And so if you go way too high in some of these materials, the grain growth is so large, it's like a brass doorknob. You see the pattern, that's a grain of the metal. These are the crystal sizes of the material. So if you fire it too high, especially on a 5Y material, you can increase the translucency for sure, but you're going to weaken it. So if a little piece chunks off on a 3Y, you're hardly going to see anything. If you chunk off something on a 5Y, you're going to notice big time. Because the size of the grains, the boundaries are much larger. If you look at all of these manufacturers, this says here, novel zirconia materials in dentistry. Someone made this beautiful chart. And if you look, it's got 3Y in the middle, and it has all the different materials, all the different manufacturers. So for instance, in the 3Y, it has Zirconzon, Cavo, VITA, Whelan, 3MSV, Dentsply, VITA, Glidewell, Toso, Whelan, Henny Zirconia in Buffalo, New York, Cure, Dentsply. All of those are 3Y. And then the same people are telling you our stuff is stronger than your stuff. And it's like, how can that be if it's the same, basically the same thing? And then you have the CPEX from Toso, you can see that. Those are 4Y zirconia, and then you see the CPEX Smile at the bottom, which is the 5Y. And of course, you can see all the strengths and everything else from literally glass ceramic crowns, etc. And so once you get to the 5Y zirconia, you can have some that measure 600 megapascals to 800. They don't go much higher than that. So don't fall for a million megapascals. So a 3-point bend test with the different materials, you can see the YZT is much stronger versus the XT, which is the soft translucent one. And these are fairly accurate, except the 3Y is probably not as strong. And so all of these it's just an indication of the more yttria you have, the larger the grain growth you have, or the grain size you have, the weaker the material is. Let's talk a little bit about nesting. Nesting used to be how many crowns you can fit in a puck. I mean, that was it. How many can I get in there without, them breaking while I'm milling? So some of the software won't allow you to put too many too close because the birds can't get in there. So you have cam software that's like this one from Dental Direct, Smart Cam 2.0, which once you install it in, I'm not sure, I've never used this, but I was reading up on it, and it'll allow you to move the crown up and down. And you can see that if you have a blank position with certain thickness of a block, you can bring it up and down until you get the color that you want. The Nacera people, which are owned by Dental Direct, they have limited color possibilities, but they have a way to nest them so that you can create, let's say, an A1 and an A2 out of the same puck. It just depends on how high and low you put it in the puck. Everybody knows that that's doing a lot of these, but there are softwares out there that will allow you to do that. So it's really helpful. And the most important thing is you have to know where the strongest layers are. If you're doing these huge cases, where are you going to put the interproximal connectors? I mean, on a big bridge, that's really scary. So you could nest it on a too small or too large a puck, and the area of the interproximal connector may not fall within a quote unquote a strong enough layer to give that connector the strength you need. Remember, it's a law of beams on connectors. It's I can't remember what it is now, but if you increase the length, you cube the strength or something. Russell knows, he'll tell me later. And so that's the whole idea, is if you have a 20 millimeter puck or a 25 millimeter or a 15, you have to change these things. And some blocks and some software allow you to see that right away, and others it just doesn't. And so there should be a universal law or rule to say, okay, if you're going to sell a puck with a bunch of layers in it on this, you need to have software that'll tell us where we're putting what. I even thought of getting a pencil. I scratched my models sometimes when I scanned some of the models, not the teeth, to test. And I put the area where the enamel, quote unquote, is clearly visible from the dentine on an anterior tooth. And that little line will show up when I scan it. And that'll tell me where I can nest it. And they should invent a pencil that glows in the dark or something to do that. So here is, I think it's layer overkill on some of these things. So this is really, I mean, incredible. I'm not sure who makes this. I picked this off of the internet, but a lot of them, I know Nacera has one that's got 4 layers or 5, but look at this. Layer 1, layer 2, gradation layer, another gradation layer, and an enamel layer. I think it's great, except if you're doing all the teeth, that's one thing. When you're doing a single anterior, you can throw this out the door because there's too many variables in a natural tooth to be able to control this. And so really the best way is to layer, if you want to layer. That's really the basics of it. You have to make a decision at some point, and a lot of times it's an economic reason that the doctor doesn't want to pay for layering. They want full contour zirconia. They don't want any quote unquote chipping or whatever, which most of those problems can be avoided if the bonding layer is applied properly, et cetera, et cetera. Another problem with zirconia is that none of it fluoresces. There is an element, and I sent the article, it's from researchers that used an element called thallium. And they put that in the Z-Pex and the Z-Pex Smile, and it fluoresced perfectly just like the teeth. but it's extremely expensive. So I don't know if that's what's holding back some of the manufacturers from doing a fluorescent zirconia. Now, most of the fluorescing elements that you could use, like you would in a regular porcelain, like a liner material, they have a very, very low fusing temperature. So if you go high, when you cook the zirconia, you can burn them out. So I don't know what these guys did, but thallium seems to work. Here's another graphic from DX Cube. You can see here you have incisal transition, gradational incisor transition, gradational body 3 transition, body 2, main body 1. I mean, that's all sounds fine. And I'm sure that would be perfect if you have 4 or 5 teeth, but single centrals, you have to luckily find a natural tooth that happens to look like your zirconia puck in order for that to work beautifully. Most of these anterior teeth, you really need to layer. That's why doctors like all these all-on-4s. They don't have to worry about any of that. They just use a bleach shade and that's it. VITA has a natural gradient, which they don't have as many of these layers on the present day blocks, and so you can have a nice change. What I do with these is when I mill, I deliberately cut back the area where the enamel is going to go, and I do my zirconia with a body shade, which looks pretty close to your classic shades, and go ahead and put enamel only, like VM9 or Lumex, on top of these because they look beautiful. So you're only using half the crown that's being layered. Then of course you have to use a lower fusing glaze in order to get the zirconia to take a gloss. So sometimes I fire translucent material, a real thin skin all over the whole thing, and then I can naturally glaze it. How do you finish the green stage zirconia before you sinter it? This is the ones that are really popular. They're made by Wagner, and they have polyurethane binders. I don't like those football shapes with the white tip. I don't understand why anybody would use those. I end up cutting the white tip off and I flatten those things so that it looks like a barrel. It's just too uncomfortable trying to finish. I mean, what are you going to finish with that big football in between proximal? Come on. So they don't really have a lot of instruments that you can smooth down an interproximal. Then they go to a sharp disc, which can dig into the zirconia. So I don't like any of that stuff. They need to make points like the diamonds that you can fit in the interproximals and smooth them out a little bit if your machine left them rough. So you see what they do is they use the green stage first to knock it down, and then they switch to the white part. I find that very uncomfortable. The only good thing is that they don't have silicone binders because that can be detrimental to the zirconia. So you need to use polyurethane binders. And if not, you're going to get all kinds of discoloration. I use these. These are much smaller, and they're from Cardinal. You get them in Europe somewhere. Everybody gets the stuff from Europe, usually from Edenta or from Jota, which make really the best finishing instruments, period. And these are very nice for the green stage. Make sure you have a vacuum turned on and a mask. Now, in the original days, we used to color the zirconia, and most of the top ceramics out there that don't really like the pre-shaded zirconia, they still do this. They still paint it, and you know it's a little bit more work. I call those avatar crowns. They look beautiful, and Enrico Steger and all those people at Zirconzon started all this, and they really are masters at it. So the whole idea is if you can't get the color from a pre-shaded puck, you're going to have to color it. The one drawback is, here's one that I did 4 years ago. or 5 years ago on a white zirconia. This is a full upper in 3 pieces on an implant case. And then I have very, very little room for porcelain, but I just have enough. And then I put the pink material on top, the gingival material. At that time, this was my first case with Lumex, which has a low fusing gingival porcelain. And the reason I like the Lumex material on zirconia is that it only fires to like 760, 770. So it doesn't burn out the color of the pigments in the zirconia. I mean, I don't know if you've seen it or not, but I did a case where I had full contour molars and I had a bicuspid that had to have a veneering material because it showed, and the zirconia wasn't that nice looking. So we layered it, and when I fired it, I noticed the occlusal table they were single units on the premolar started to get lighter than the molars, and I'm like, what the heck did I do here? I just fired it, and of course, that was with the VM9, which was a 900 plus firing temperature. So I don't see it that much anymore, but I use both VM9 and Lumex, and they work beautiful on zirconia. I use Lumex because I can also put it on glass ceramic, like an Emax CAD or Ambria, which is to me the prettiest, and the VITA block. So there's three materials that you can use Lumex on, and the labs really need to rethink. They need to use one porcelain on everything instead of having 3 porcelains to do stuff. Now, why do zirconia crowns appear to match a shade guide on the bench, but they look bright in the mouth? That's always been the case. Now, some 5Y zirconia actually look too gray in the mouth. And if you glaze it or have to touch the surface, you polish it, it all looks like a pearl. And a lot of people don't like that. I don't really mind it, but I layer just about everything. The reason for this bright look, especially in the 3Y material, like the Nobel BioCare abutments, those are so bright that you have to compensate. So if you have like 0.5 millimeter or 0.7 of a veneering material, and you think you're going to put that on there and mask out the brightness of that zirconia abutment, you're crazy. So you have to compensate. And that's why I always use a 3D porcelain on any of these Nobel BioCare cases. I'll show them to you. And so what happens is if my target is, let's say, a 3M1, and I get these, they only have like 5 colors, and then none of them look like anything. And so I get them so they're quite a bit brighter. So what I do is I do a bonding layer with a much darker dentine, like a base dentine from a 4M1 or a 5M1, and look at it, and I'm telling you, it'll end up looking like a 3M1. That's how bright some of those abutments are. The reason for this is the birefringence, which basically a lot of these materials reflect the light from the crystal and from the boundary. And so that causes what's known as a birefringence, which is 2 light rays coming off of that material, and it appears bright. And the test for that is you put any of these, like this calcite crystal, on top of a pencil, and you actually see 2 pencils. I've never seen that in person, but it'd be cool to look at. So the birefringence is a phenomenon exhibited by certain materials in which an incident ray of light is split into 2 rays, called an ordinary ray and an extraordinary ray, which are plane, they're linear, polarized in mutually orthogonal planes, or circular polarized in opposite directions. So that's what causes this double refraction, which causes it to look bright. Now, as you increase the yttria content, you reduce this birefringence because the light is going through these larger crystals like they do a big ice cube. So you can take a water and really freeze it slowly so there's no air in it whatsoever trapped, and it's clear as a bell. Now you take and start grinding it down to make an icy, and it gets white. That's like snow. You take snow and put it in a cup, and it'll turn clear. So it's the light bouncing off of these little crystals, and that's why it looks brighter. So the finer the crystal size, the reflection is greater. Now, the other thing is the refractive index of zirconia is much higher than that of ceramic material. So glass is about 1.5, air is 1, zirconia is about 2.1. And the reason a lot of these porcelains look pretty good in the mouth is if you put a refractive index material of 1.5 plus 2.1 and divide by 2, you get around 1.6, which is about the refractive index of a natural tooth. So the old alpha porcelain and the inceram material look so beautiful in the mouth is because the cumulative refractive index was the same as the tooth. If you just had a little bit of room, you could make them disappear, just like you can now. You just have to layer. It's very hard to make a regular straight zirconia crown match a single central. There's too much going on inside of those things. So let's just look at some basic facts about zirconia. The pre-shaded multi-layered pucks are the most popular. That doesn't mean that they come in all shades. The thicker the crown, the more chroma it's going to have. So if you have a lot of reduction on one prep or a Pontic next to a crown, Pontic's always going to look different. I'm sorry, it just is. Nesting to control the layers is essential. If you have a multi-layer puck, you have to remember what we do a lot of times is we go ahead and mill it, and we have a little finish line on the thinner crown. And then once everything is cooked, we look at it and say, okay, how close is it to the target shade? And if the Pontic is close to the target shade, I'll get some porcelain and build up the crown next to it if you want everything to look the same. The other problem is if you over or under fire or under sinter zirconia, it changes the appearance a lot. So you could have the best zirconia in the world, but if you don't fire it properly, you're screwed. So slightly under sintered zirconia increases the chroma. Slightly over sintered decreases the chroma. Fast sintering is not the best method, and the fast sintering reduces translucency. I know they're working on all kinds of zirconia, and they'll say, yeah, you can cook this thing in an hour. It's like name that tune. I can cook that crown in 3 bakes. I can cook it in 2 bakes. Oh, bake that crown. And so it's incredible. And so once you start trying to fast fire some of these things, they'll call me up every time. You know what? This thing doesn't look right. It doesn't look like the shade tab. It looks dead. Well, first of all, a shade guide is made out of glass ceramic, and zirconia is zirconia, which is not a glass ceramic, so you can't expect them to look 100% the same. So we basically made a custom zirconia shade guide. And really, with the doctors today, all you need to do is make a bleach shade and a 1M1 or A1 or B1. That's it, because if the bigger the case, the whiter it gets. And so let's look at some of the problems that you can have in the lab with zirconia. So we know that the firing method can definitely affect the strength. Excessive grinding after you sinter it can be dangerous, no question about that. Fast firing veneering porcelain on zirconia will cause it to lift, and I'll show you. Fast cooling of zirconia is also very dangerous. And the worst is when the doctor grinds it in the mouth after cementation, he better know what he's doing, because he can cause a lot of damage. And they should look at that before they cement it and say, you know what, this is too high or too low. I don't understand how that happens, how you can cement a crown and then grind the heck out of it. So look at the sintering recommendations for this one. Happens to be VITA. Look at the T universal. So you have 88 minutes total. Look at the ST, 188 minutes to climb. And the XT, these are long cycles. And so whenever you try to do these super fast, something's got to give. Now, I know that they claim they're making zirconia just for fast firing. I've never used those. I'm not interested until I see somebody else use them. And if they look pretty good, I mean, what are you going to do? So you have to stick with what's working for you and do a little experimentation, but don't do it on a real case. What we have to really think about is when you sinter zirconia, you have to think about the mass of the material. How big is it? Everybody always gives you, look at this, YZ universal or whatever. What does that mean? So when you're cooking something, you say to yourself, all right. So if you look at the picture on the left, you see slow. Now look where it says 2 degrees per minute from so-and-so, and then 2 degrees from this one to that one, and then you hold, and then you slowly walk it down. And so you're talking 13 hours. The other one is a little bit fast fire where it climbs up and you're going 17 degrees a minute, 17 a minute, and then you drop down. The cooling is really important. So you have fast and slow cooking, but the bigger the mass is, the bigger the Pontics are. If you have a tissue flange, whatever it is that you're doing, if they're big, huge cases, you got to get another oven and go home and let it cook and let it cool down and sleep tight. If you try to rush it, it'll fail eventually. Here's a study done by B&V Origin, and they tested 4 different ovens. They used a standard oven, oven 2, 3, and 4, and they milled it out of the same puck. And some of the ovens were 1 to 3 years of service, and they had the heating elements, which I'll go over in a minute. And you can see oven 4, actual shade results. Intended shade is an A3. They fired it at 1550. That shade came out darker. Oven 3, the shade came out lighter. Oven 2, the shade came out darker. And the first oven, it came out okay. So, so you have what's called set temperature and performance temperature, okay? So if you can set your oven to whatever you want, that doesn't mean it's firing that way. And I'll go over how you can calibrate your oven. Here's from Adite. So if you look, it says here below 3 units, 7 hours, the cycle. 4 to 6 units, that one is 10 hours. This is 7-unit bridge and above, 15 hours. So there's a lot of manufacturers that are telling you, slow it down, take it easy, and very well done graphs, etc. So we know that if you take the same zirconia like the ZPEX, this is from Toso. You can see at 1300, you can see the grain size change as you go up in temperature. So this is what you have to remember too, that not only the sintering temperature matters, but the cooling temperature matters as well. The slower, the better. So initially you have about a 30% shrinkage from the zirconia, partially sintered 20 to 25%. And so that's a before and after. And it's amazing how little that little crown looks. I was thinking of making big dies so I could check the margins, but that doesn't work. So let's go over calibration. Unless your oven is firing the right way, you're never going to get the look of the zirconia that you want. There's a German company called Ferro, which makes temperature processing rings. They're called process temperature control rings, PTCR. And this is a little machine they have, which is about $300 to measure the before and after when you cook these things in the furnace. So basically, if you have a zirconia, if you look at where my little red star is here, it says 1340 to 1520 and 1450 to 1750. So if you wanted to check your temperatures from 1450 to 1750, you need to buy the PTCR ring HTH. The L just means that it's a smaller ring, okay? So get the bigger ring, the 20 millimeter outside diameter. And then after you go through a sintering process, every batch of zirconia rings that they sell you comes with a paper with the shrinkage factor and the temperature allotted to it. So the mistake that I made was saying, well, I want to put it in there while my crowns are in there, which sounds novel. The problem is the longer that the ring stays in there, the more it shrinks. So I put a shrunk ring in there and I put a new one next to it, and you can see how small that is. And what happened was I put like a 4-hour hold and it kept shrinking down to nothing. So when I tested it and I looked at the chart, you can see at 18 millimeters, it starts off at 20. The outside diameter is 20. So if you read down here at 1803, that means my furnace was supposed to be at 1676 degrees more or less, which is way high because I set it at 1500. And so there's no way. So I called the Faro company and they said that those rings shouldn't stay in there very long at all because that they continue to shrink. And so I tested them again, and I put down 1450, which is what the temperature for the VITA ST material is. So I put the ring in there and I ran it up and I left it for what they told me to leave it, which was a 1 hour. And when I brought it down, I measured it and it measured 19.63. And so that is my standard for VITA ST. I know that if that ring comes down and it shrinks from 20 millimeters to 19.63, I'm going to be around 1460, 1450, okay? So if it comes between these, I'm happy. I've never gotten one to go exactly to 1450, but it's just a matter of tinkering with it. And again, what do you do on the bigger cases? So I know the furnace is at the right temperature, and how long you leave the zirconia in there is irrelevant because the rings are not going to be in there. So we know that we're holding it at 1450 for X number of hours, and that's what the zirconia needs to change to a sintered body. So let's look at the furnaces. Whoops. These furnaces from VITA and most of these other ones, they use what's called molybdenum disilicide, which is a MOSI 2 element. The picture on the left shows a fairly new furnace. I just stuck a mirror in there and photographed mine. And then I had to go to a lab to look at their elements, and they had already taken them out, and this is what they look like, which this means it's time to replace it. So the Si2 silica, it's basically a coating that's around this molybdenum, and it's a glass coating which protects the molybdenum from oxidizing. Now, if you use a lot of acid early on to cook your work, to color the zirconia, if you didn't burn those out in a light, the fumes would eat up that glass because that glass, hydrochloric acid, dissolves glass, etches it. And so once these elements become like this, there's no way they're going to work properly. Now, sometimes you'll see little tiny green contamination that falls on the zirconia beads or whatever pad you're firing it on. And sometimes on the work itself, you'll see like little green dots. That's not the element molybdenum. That doesn't leave any color. but it's the glass. So the natural color of silica is a greenish. And there's a beautiful booklet by a company in Germany, which I'll remember in a second, but they make the elements for the VITA furnaces, and they make the insulation, they make everything just for ceramic furnace applications. And they had a beautiful explanation, and they actually contaminated deliberately with all kinds of different elements to see what color they would use, and you could see that none of them except the glass from the little chips of this silica were the offending ones that would cause the discoloration on some zirconia. These are silicon carbide elements that are present in some other furnaces. They look like an implant to me. So there's a controversy. They'll say, well, this one's more accurate than that one, or this one lasts longer, or this one doesn't have a glass coating, so you won't ever have that. But they show the life of these elements are supposed to be shorter than those of the molybdenum disilicide elements. So I don't really know the truth on that one. As long as they work, that's all you care about. So what happens to zirconia if you blast it too hard or grind on it? So we know that if you put too much pressure on the zirconia, it'll actually push back. And then you can air abrade, but it should be about 30 psi with 50 micron aluminum oxide. What I've done is, since you have to blast out sometimes the crowns when you layer them, refractory material to hold the bridges in place, I blasted out the VITA one because it sticks. I don't like that one so much, but a lot of them are like that. They have like a little tacky thing which holds it up nicely, but to take it out is more of a bear. And what I do is I used one of the tanks in the blaster with baking soda. Now, any of those things absorb moisture. So what I did, well, let's go to here. So what happens if you press too much on zirconia? So this is the most problematic situation when you have 3Y zirconia, where that stuff, it pushes back. It's almost like if a big bad wolf is at your front door and all your friends, once they hear the door starting to cave in, they gather around and push back to keep the wolf from coming in. So the crack is stopped by a phase transformation. And so that produces 3 to 4% expansion. And that's what keeps zirconia so strong. It changes from a tetragonal phase to a monoclinic phase. And then what happens is, if you keep on, is called grain pulling due to grinding and hydrolysis. This is a study by Jerome Chevalier from 2006. And a lot of people don't believe this, but it happened in hip implants in a company in Switzerland. I can't remember which one, but they make hip femoral heads. And 1 year in 2003, a lot of them started breaking inside the people. And then Chevalier studied the surface of a lot of these removed femoral heads and saw the abrasion, and they noticed this grain pulling, so that if you have too much stress, these grains grow out, and then the water comes in and it's absorbed, and that starts to weaken the zirconia. The nice thing about type 4 and type 5 zirconia, the 4Y and 5Y, is that they're less susceptible to hydrolysis and phase-induced changes, because cubic can't go to a monoclinic, but tetragonal can go to monoclinic. So that's the good news. Some of the older zirconias, you have to be careful how hard you grind on them and how hard you sandblast, just like the new ones. So what I did is, I either get a nitrogen blaster, or I put these little silica gel packs. I drop them in my tank where the aluminum oxide and the baking soda are, and then I have a humidity indicator and I drop it in there. And if your aluminum oxide blaster keeps sticking and you got to keep blowing it and cleaning it, 9 out of 10 times it's moisture. And this really helps to put a couple of silica packs in there and just change them out. And, you know, I clean mine. I got to clean mine now. It's half a year, so I do it every 6 months. But that really helps. The other thing I do is I use blue food color. And I do that to test to see if any of my veneering porcelain lifted off of the zirconia. So what happens is if you go too fast and you need to slightly aerabrate the surface, you see how shiny that coping is from the bonding layer? That's because the bonding layer cooked twice. I cut that crown in half, but that was flat, okay? But still, if you dry it too quick and you fire it too quick, the ceramic will shrink and pull up on itself and it lifts off the margin. And the blue dye can tell you how bad it is. So just to let you know, you have to be really careful when you do this. Remember, the zirconia takes a long time to heat up, really a long time. And especially if you put the putty inside the pegs, that doesn't help either to heat it quicker. So when you have a little coping, it's not even as bad as if you have a big crown, where you have to get that zirconia hot enough so that when that VM9 or Lumex starts to turn into glass, it can wet the surface. If you don't preheat it enough, that would be 400 for about 6 or 7 minutes. You got to make sure that happens. If not, you can get lifting from your veneering material because it just doesn't heat up to accept the porcelain. The glass transition temperature of the Lumex is 565, I believe. And so you have to be careful that you're in that range, and then it'll start to stick really well. There's no problem with bonding. It has the highest bond strength of any low fusing ceramic. So if you do decide to layer, you need to use a low fusing ceramic better than a high fusing one. It saves on the cooling time a lot. I like to go below 850 for glazing and everything because if you have some coloration, it might burn it away. So you could have an A3 and you end up with an A2 on some full contour crowns. But if you're layering, the facial, the occlusal table will get lighter. And that's because the pigments inside close to the surface are being oxidized away. That's my conclusion. I've seen it happen too many times. So the bonding temperature is critical. You need to get a little bit higher, go at a slow rate of climb, lowest possible firing temperature till you see glass develop, which is about 800 in the Lumex material. It's around 910 on the VM9. And slow cool rates, especially for large cases. We already talked about that. So remember, repeating, zirconia has a low thermal conductivity. It takes a long time to heat up and a long time to cool down. The temperatures, the bonding temperatures must be at least 80 degrees centigrade higher than the normal firing temperature. The liners and bonders also vary in temperature, so you have to keep an eye on that. And special attention to the margins. So you can have where you want to just pick up a little margin with something, and if you go too high, that'll lift. So in some situations, I've used the VM9 margin material on a really, difficult gingival case where I have to have this almost like a paragingival prep. I get the VM9 margin, which fires like at 930, and then I go back with Lumex, which goes to 760, so I don't distort any margin. So porcelain layer delamination is possible. Shrinkage, overbuilding shrinks away from the margin. You have to blast the sheen off of the bonding layer, and you should only go to 30 psi with 50 micron aluminum oxide and a rate of climb of about 25 degrees Celsius per minute from low temperature to high temperature. So if you're going from 400 to 750, that's 350 degrees at 25. That's close to 8 or 9 minutes. Now, how do you know your furnace is on the money? In 1987, Vanek and I and Dr. Klaus, we were fighting with Dentsupply over this fast fire furnaces that they had. And Dr. Klaus made a chart that showed the speed of the fire and the high temperature. And so you could achieve both, but the best way to do this is to take a coping of the material that you're going to layer, and you build it up with window porcelain or clear porcelain, whatever you have, and build it up and extend it a little bit. And then you just take the end of your brush and you chip away a little bit at the margins. And when you fire that, if that edge is still sharp and the material is clear, then you've got the temperature honed in perfectly. Just because you set the furnace on whatever temperature doesn't mean it's going to bake that way, because your thermodynamic situation changes all the time. So if you were to fire a Pontic and some veneering material on the Pontic, and then you did a real thin little crown, that porcelain is going to be, it's going to take longer for it to heat up, and it's going to take longer for it to cool down, and it may have a slightly different look. You have to accept that because of the mass difference between these units. Let's go to this. Here's the color that I used for regular crowns. This is old. Now look at the color on the posterior units. The only one that's been layered is the first premolar, and look how light the occlusal surface is. It's the same shade. And I said, why is this getting lighter? And I called Bob Kelly. He had never heard of it. And so I've talked to a few labs and they've noticed something. And so I started dropping temperature. I tested a bunch of them. And if I stayed below 850 for glazing, I had a real good shot at not changing anything on a full contour crown or otherwise. There's a company called Apsara that makes some pretty decent zirconia. They're in Mongolia. And I was asked to attend a meeting at Americana Dental in Tampa, and I met the ceramic engineers from Apsara because my friend Pedro Fernandez was going to distribute, or thinking of distributing it, and he wanted me to help him to see if this was worth it or not. And what they did is, when I was up there, the girl ceramic engineer handed me this little bag of charcoal. And I jokingly said, oh, was I a bad boy the whole year? Of course, she didn't get the joke. But the coal, the little charcoal, they sprinkled it in a little tray. And when they ran their zirconia up to put color and whatever on it to build it up, that produces a CO2 atmosphere, which is a neutral, I guess. And so it didn't oxidize away. And then I remember VITA made a big charcoal disc on a metal tray that you would put these blocks, you would put your firing pins on top of this metal tray with a big gigantic charcoal, and then that produced CO2 to keep the oxidation level down on base metal alloys, non-precious. And now Renford has these little charcoal blocks in this tray. So if you want to reduce the oxidation on anything, you can fire these little carbon blocks. It's called active carbon from Renford, and that helps. Now you can use concentrated colors. This is white zirconia painted with the different colorants from, I think, Zirconzon or VITA. They're pretty much the same thing. These were the ones that are low acid. And you can get some beautiful results. So a lot of times I would paint a little bit on the occlusal table to make sure it was a little bit warmer. But there's group 1, 2, 3, 4, and 5. Now see, look at this case. This is an implant case. And this is how bright these abutments are. This is called ASC abutment, which stands for angulated screw channel. So this whole abutment or molars are held in place by a little tiny base. And you tighten it, and the 3 prongs stick out of that base. It goes against every principle on zirconia that's under tension. It's not really under compression, so I don't know how it works. So if my target is a 3M1, I would use a 4M1 to coat the material with to reduce the value, and then I would go ahead and layer with my target color. So that's how I did it. So sometimes you have to compensate because the colors aren't right in the zirconia material that you get. Now let's go over a few not so easy cases. This is a dentist that I used to work for that he decided to use a certain shape of tooth, a VITA tooth, to produce the quote unquote the template for this guy's full arch in zirconia on a titanium frame. So as soon as I saw the teeth, I said, these aren't going to look right. Of course, he lost his head. And he said, why do you say that? I said, because the interdental papilla is going to be like 5 feet long, and it has nothing to do with what this guy needs. So what I did is I took the design parameters and I redesigned them on the scanner. And what I did is I increased the contact surface between the centrals and the laterals to give this guy some normal looking teeth, because look at the diastema in the middle slide. Look how far down it goes. That's a very tapering tooth. And if you want long papillas, that's one thing, but that's excessive. So you either grind the teeth down or you redesign them. So we went ahead and did the case, and he actually got these 2 crowns made so that he was going to prove me wrong. And there you see the ones that I did on the right hand side on number 9, I guess, or the left. And you look at that. So the papilla would be so far down it wouldn't look natural. And so sometimes you can, wishful thinking, but you have to think of what biotype of tissue this guy had. Was it a thin biotype, thick biotype? And you really should have picked that up in the try-in, but if not, the papillas were going to be ridiculous. So there's the impression, there's the mounting, there's the framework. This was done in Canada, but I can't remember the name of the company. But they were the only game in town back then. So they did a nice job. And then what I did is I built the porcelain up. And these 2, the central, the lateral, and the canine, come off, because there's no way to do an access hole to remove it if the doctor wanted to remove it. So we did a little splint there, and those are temporarily cemented. And they've been in there for 12 years now, 10 or 12 years. And we just did his lower arch. So the only problem was the denture guy didn't use the veins in the characterized lucitone. You see that? Upstairs. So that is, what do they call it? It's that resin from Italy, an accident. But he should have used the fibered ones to match the denture on the bottom. Here's another case that we designed on a cancer patient, and here's how we did it. Now remember something. When you're doing when you're doing a lot of tissue flanges and things like this, sometimes it's better to use the white zirconia unless you have a very light shade. Because when you try to layer the pink porcelain on top of a darker color, it'll never look pink like the tissue in the human mouth. So if you have a white background, the pink will look absolutely beautiful. Or you use a real light pink to color the zirconia. which is what we did here on the second slide on the bottom left. That is a fairly light shade, and then we put a little pink coloring before we sintered it. The upstairs is a resin. And then I built this up with the different goodies. Put some more stuff in there, light dark contrast, and change your colors and translucency. So always mix these powders with clear 50-50 minimum. Maybe a little straight porcelain here and there, but just mix it up sloppy on your glass slab and it'll come out perfect. And there you can see the finished work. And there it is in the mouth. So you can get some nice looking results, but you have to think a little bit on the zirconia background. What are you going to use? You're going to use a dark one or a light one. So remember, pink on top of white looks pink. Pink on top of anything that's a little yellowish will look orange. So think of the color combinations and change the translucencies around, and it'll make it appear more natural. Is it going to be perfect? Not for me, it's not, but it's very close. Anyway, I appreciate your time today, and thank you very much.
Well, thank you, Felix. It was much appreciated, all that information. So it was really good going over the process and all the trials, errors. I'm sure everybody was happy that you did all the testing and they didn't have to. So great information. So
Yeah,
we do have
I have more time on my hands now to mess around.
some quite a few questions before we get into them. Everybody, we did record the webinar. It'll be posted in a couple days on the VITA North America YouTube channel. So just type in Felix Pages and it'll go right to it. We also have other Felix Pages webinars that are already been recorded and are posted. So you can see all sorts of different topics that Felix has been gracious enough to provide us and you on learning about zirconia, layering porcelains, and pretty much anything you want. So we appreciate that, Felix.
My pleasure.
So a couple questions. I sinter all my zirconia using one cycle. Is that okay?
No, it depends on the size of the units. I mean, like I showed you in the graphs, from more than one manufacturer, the larger the case, the larger the mass, the slower you should cook it, and the slower you should cool it. When you have real thin little crowns, it's okay to go a little faster. And if your zirconia is all the same, you might have that temperature dialed in. The only thing that you really need to look at, if it's a safe cycle, it's always better to go with a slower cycle no matter what. So if you're trying to use a big case on a fast cycle, you can run into problems. That's really the consensus of everybody that I know and talk to. You can get away with it sometimes, no question about it. But it's like I said, if you have a large mass or a flange, that's a lot of material there. And if you try to cook it too fast, it's done. That's why I always tell people to get another porcelain oven if you're layering. And then once you finish these big arches with porcelain on it, just let it cool down inside the furnace and go home. You get it the next morning, because if you try to rush it, you're just asking for trouble.
Yeah, like you mentioned, all the zirconia is not made equal.
Oh no.
You got to watch the manufacturer's instructions. Kind of a related issue to that is that this one person says, well, when I glaze my larger frameworks, just glazing, sometimes they come out whitish. They're not glossy.
Yes, that's because your cycle is too fast. And what happens is it takes a long time for that zirconia to heat up. I mean, that I've had that happen to me. I had a Pontic, a simple 3-unit bridge, and I went ahead and I put my LT glaze, which goes to like 780. And remember, none of these are veneered. These were full contour zirconia crowns. And I painted them with the glaze. I set them there and I watched them all turn white. Okay. And I ran it up from 400 to 780. And the two crowns on either side of the Pontic came out okay, not with the highest sheen, but the Pontic was white. And I said, that means it's not getting enough heat. So I slowed the rate down and I went up on the temperature. So I glaze like anywhere below 850, you're good. If you're not layering with low fusing ceramic, you can glaze it as high as you want. Just like I said before, if you choose a higher glaze temperature, it's going to take longer to cool down. If you can glaze it at 800, 820, let it cool down, but it's not going to take a day and a half. You know what I mean? But that's why the glass is not being activated. So you have glass powder and it's not heating up enough to turn into a glass.
All right.
That's what happened there.
And then you showed someone had a question about when you did your calibration on the sintering furnace. Do you always place those calibration rings on the pearls, or do you ever put them directly on the platform?
Doesn't matter. Remember, when these things shrink, you know, you look up at Faro and they have all different things. Every time you go to a company, it'll have a different thing on how you should set your, put your rings, whether it's on a pad that they have or on the tray itself. And I don't know how. I mean, I know it doesn't shrink that fast, but if you had a rough surface, it would grab that rough surface while it's trying to shrink. Whereas on the beads, it'll roll. But I don't think it matters that much. The most important thing in there is not to leave that ring in there too long. That's the mistake I made. I said, well, I'm going to hold this. I was trying to figure out why I couldn't get enough translucency from an adite zirconia. And, it's when you speak to somebody, translucency is relative. So this was not a multi-layer. This was a regular zirconia, an inexpensive one. And I was trying to test it. I said, let me see what's going on here. And I could not get that thing to look translucent. So I said, well, I'm going to hold it longer. And what happened was that little the little ring shrank like crazy. And I said, I can't be up to 1600. And that's when I called Faro. And I talked to this guy, very nice guy. And he said, no. You can't leave it in there too long because it's a function of time and temperature. So it'll shrink quite a bit. And those testing rings, you can leave them in there for a few minutes. The longer you leave them in there, the more they're going to shrink. So I haven't got the ideal answer for you because no one's given me the ideal answer for me. I don't know. I know that Faro says about an hour. You can go on their website and it'll explain a lot. They're a very good company.
Kind of interrelated, you slightly mentioned it, but somebody had a question on if I leave my zirconia in longer, can I make it more translucent?
Usually the temperature, a little bit of a rise in temperature is what makes it more translucent. Not exactly the whole time. So you might increase it, and it's hard to say because all those furnaces, you can be 50 degrees up and down, and it's pretty forgiving. You're going to get an acceptable material. What kind of zirconia is he using? A 4Y? If it's a 4Y, you're going to have a limit to that translucency depending on how it's layered. So you could have a 4Y that's like the way that the VITA does it with their pucks, to where it's like a gradual descending color versus one that has enamel on it. So that if you were using a 4Y multi-layer puck that has real clear, distinct areas where the enamel is, you can nest it up higher so that you have more enamel covering the crown. And that'll make it appear more translucent. But typically it's a function of the temperature going from say 1500 or 1450 to 1500 or 1550, somewhere in that range.
Okay. And then another question is, have you done veneers using a zirconia?
I think that's crazy. I mean, to be perfectly honest with you, because number one, the bond strength of a veneer. Think of what you're doing when you're prepping a veneer. You're just skinning the enamel off. If it's a young person, why would you want to skin the enamel off? The best bonding happens when you reduce the enamel by less than half a millimeter, where all the enamel prisms, everything is just fresh, the rods are, and that you can get a really good bond to. Once you have an older patient that may have had something going on in there already, and you try to prep down, if you remove too much enamel, it's not going to bond. It won't bond to dentine, so you have to make sure you're in enamel for the best bonding, and that's with an MDP resin, but I find that ridiculous. Now here's another thing. How many regular veneers have been done over the years where a doctor will send back a case and say, hey, the central cracked or the lateral cracked or whatever, and then you do it again and the same tooth cracks again. And they keep blaming the lab. And that's absolute BS, because what happens is they've gone through the enamel and you have an area where you have enamel that's etched, then you have an area where the dentine has been exposed, and then you have more enamel. And you can actually see by the way the crack runs where he went through the enamel into the dentin. So then they bond the veneer, and then you have compression where there's enamel, and compression and tension where there's dentine, and then another compression, and that causes a crack, and it keeps happening, and the more you prep it, the worse it's going to get. So that guy turned it into a crown prep instead of a veneer prep. So they can say all they want, but I've seen too many veneers that they've dug in too deep and they come off. And with the zirconia, I just don't see the advantage. I mean, once a veneer is put on the mouth the right way with a glass ceramic that you can etch and bond, the strength of those go up ridiculous. And I don't see how, I mean, these things just don't fall off for the heck of it. It's when the doctor goes through the enamel and they're trying to bond to dentin, which is really minuscule bond strength compared to the enamel. That's the problem. And the zirconia, I don't understand, because number one, try to mill out a veneer at half a millimeter with zirconia. Sometimes they're going to break while you're milling. You got to really be careful. You have to have some special machine if you don't want to finish down much. Now, if you're how thick is your veneer going to be? Is it going to be a millimeter thick? That's not a veneer. And so when you think about how thick the veneer is and say, well, how am I going to mill something that thin? So you either do them Cerac, and then you can take them down by hand with a diamond and water, and they work just fine. So I do a lot of VITA block veneers. They look better than anything else. And they melt at 1200 Celsius. So no margin moves, nothing. And then you can put any porcelain you want on it that's matched in expansion to zirconia, like VM9 or Lumex and any other ones. So it's a huge advantage, but I stay away from the zirconia veneers.
Yeah, there's so many other materials that are a little bit more cosmetic. So on someone had a question, a follow-up question on the glazing of a monolithic or full contour crown.
Yeah.
What would the ramp rate be? What would the high temperature be that you could set it at?
So we know that the VITA LT glaze will work from like 750 is about the lowest that I would use, up to 1,000, no problem. So if you have full contour zirconia crowns, my cycle is I start off at around 400, but I make sure the thicker the crown is, the longer that it stays in the preheat. So my rate of climb would be about 25 degrees per minute, slow. And then I go up. The slower you go, the lower in temperature you can go. So it's time and temperature. So if your crown is hot enough, it'll activate that glaze as low as 760. But if you ramp the crown up too fast, that big molar is not going to be at 750. It's going to be colder, and it won't take the glaze well. You'll have a lower looking glaze. It won't melt it. So the thicker the crown, the slower you go up. And I would stick to a temperature around 800 if it's a full contour zirconia crown. Paint it with the LC glaze, set it there in front of you till they turn white, and then run it up to where it preheats about like 5 minutes at 400, and up you go. And slow it down. The bigger the case, the slower you cool it.
Okay. So, last final question we have here is how do you apply? This person having some issues glazing a polished zirconia surface. What's your technique to have the glaze lay down onto a polished zirconia
If you
surface?
have a polished, first of all, if you polish, let's say you're doing an implant crown, the part that exits the implant, the whatever you call it, the tie base, whatever, up to the clinical crown, that should never be glazed. Glaze attracts bacteria because it's porous. So all of my crowns, I polish them from where it touches the titanium all the way to where it exits the tissue. All that is polished. The rest of the crown you can glaze facially and lingually, whatever. I don't ever put glaze on the contacts. In fact, I've got a guy working on a program now that we're trying to create the most minuscule of a finish line on a full contour zirconia crown, because we never glaze the occlusal table either. It's always polished.
Oh, is that right?
Yes, you can read the study by Glidewell and Gordon Christensen and many other authors for many years, that what happens is the glaze starts to go away. They did a comparison between how the glaze stuck to Emax versus a zirconia crown, and they both started to come off sometimes 3 months, sometimes 6 months. But if you have a glazed crown and you want to reduce the surface tension, you may not believe me, but I take Ajax and a toothbrush and I scrub it, rinse it, dry it, and it'll go on just fine. Now, the other thing you can do is take like a 20 micron red stripe diamond with water and go over that surface, and then you can put your glaze on it. That's a very good question. The other thing you could do is if you have 25 micron aluminum oxide, not 50, 25, you could stay far away from it and just give it a kiss, and that'll work as well. Now, why 25 versus 50? It's just like in metal ceramic. If your opaque is really, really fine powder, you don't need that much of a depth so that the particles of the opaque will fit in a little hole, like a valley in a mountain. And you need less opaque to cover a crown, especially on high gold that's been blasted with 25 micron versus 50. And that's it. It's like I tell people, if you try to pour honey on top of aquarium gravel, you're going to trap a lot of air. So if you have a real rough metal surface or a rough zirconia surface and you try to put stuff on it, you're going to trap air. But if it's smoother, it'll flow and push the air out of the way. So I do that a lot. I do some polishing and then I scrub it and then I paint it with a glaze.
All right.
Go home and try it.
It'll
Do not
leave.
try this at home.
All right.
That's
Well,
a very good question.
well, thanks, Felix, for all your time today, taking it out to educate all of us. Greatly appreciated. Any last parting words to the audience?
Well, this is an emerging, I don't even want to call it an emerging technology. It's an emerging material situation. Of where every day we're getting bombarded with every kind of zirconia ever. And right now, like I just saw those 7 or 8 layers on a puck. I mean, that to me, it's almost like too much. And they're gasping at straws to be able to do a full contour zirconia crown and not ever have to put porcelain on it. And that's just, you can do it, but it's not the best way to do it. If you're trying to match a couple of single teeth and all that, it's almost impossible. Like I said before, you have to get lucky and have a patient that comes in with a color of a tooth that's the same as your zirconia.
Yeah.
Now, one thing that I would do is go ahead and get a puck of whatever you use and mill out 16 of those suckers, right? You mill out an A1, an A2, A3, whatever, and fire them up. Full contour zirconia, pre-shaded, layered, and make a shade guide out of zirconia. That way you know what your target is. If a doctor wants an A1 and you try to take a shade with a regular shade guide, that shade guide is a glass ceramic. It has nothing to do with a full contour zirconia crown. But if you do a full contour zirconia layered, multi-layer shade guide, you'll be much better. You'll be able to predict much better how close it's going to look to the natural tooth when you're doing the whole thing out of zirconia. You see what I mean?
Oh yeah, definitely.
So that's an issue there. You have to spend some time and make your own shade guide. And like I said, a lot of these guys just want A1, OM1, whatever, BL, whatever they are, 3, 4, all those super light colors. I mean, everything looks white with some pink on it. And if they want to look that way, that's fine, but there has to be something that looks more natural. I mean, I don't know. I have a feeling this will be like ties. Everybody wants skinny ties now, then the big wide ties come back in.
Yeah,
And
that's
at
right.
some point, somebody's gonna say, you know what? I look like a fool with these white teeth. I mean, some of the stuff I see on television, it's just outrageous. But anyhow, like they say, it's a living.
Yeah. Yep.
But that's what I would do to increase your predictability in anything that you do. You have to reproduce the natural situation. So if you're doing a lot of zirconia, full contour crowns, you have if you go take the shades, you make yourself a custom shade guide.
Yeah, and
That,
there's no reason why the laboratory can't make a deal with the dentist and either sell it to him or say, hey, if you give
yeah,
me up, your work, your zirconia work, I'll provide you with a
right.
custom zirconia shade guide. So,
Yeah.
all right.
And you remember each zirconia looks a little different.
Yep. Yep.
Well, thank you guys very much.
All right. Well, thank you
Uh,
very much, Felix.
all right.
Wonderful, great information. And I want to thank everybody for joining us today and listening to Felix. Join us again. We've got many webinars coming on for the rest of the year. And Felix will be doing a couple more as well. We'll advertise those out, market those out to you. So as far as today, this will end today's webinar. Thank you very much for attending, everyone.